Hello, and welcome to the Biomass Magazine podcast. I'm your host, Anna Simet. On today's episode, we're continuing our International Biomass Conference and Expo panel preview series. And joining us for this edition, we have Jayant Khambekar, Senior Consultant at Jenike Johanson. Jayant, hello, and welcome to the podcast.
Thank you, Anna.
It's great to have you here. So you have been with Jenike Johanson for 17 years now, since 2007, and you currently head their Houston office. So why don't you tell us about your journey so far?
Sure. I'm a mechanical engineer by training. I did my PhD in granular flows at Worcester Polytechnic Institute. And right after that, I joined Jenike Johanson and have been with the company for about 17 years now. Initially, when I joined the company, I worked on discrete element modeling or a lot of projects involving discrete element modeling. It was quite new field at that time. It has progressed quite a bit now, but worked on that. And as you may know, the core business of Jenike Johanson is really using technology to achieve reliable flow of bulk materials. This includes designing of bins, feeders, transfer chutes, pneumatic conveying lines. So till date, I've worked on more than 300 different projects in various industries, really food, pharmaceuticals, of course, biomass, and plastics, mining, power, a really wide area of industries wherever bulk materials are handled. And then about 10 years ago, I moved from our headquarters in Boston area to Houston to start our office in this area. And we have been in these 10 years, we have been growing the office. I'm also involved in teaching courses on solids flow and pneumatic conveying, presenting at conferences, writing articles on solids flow. All in all, it has been a fantastic journey with Jenike Johanson. As a matter of fact, just a month ago, Jenike Johanson was recognized among the top places to work by the Boston Globe. So Really a fantastic ride so far.
That's wonderful. 300 projects, that's really impressive. So as a consultant, Jayant, you routinely get to visit different plants. So what's your view of the current state of the biofuels industry, especially with respect to making advanced biofuels or cellulosic biofuels?
Sure. If you look at the field of biofuels, at least in my view of the field, I tend to break it down into different groups or categories. So certainly within biofuels, there is a category. If you look at ethanol from corn, there is that type of biofuels production. Now, the prospect or the growth prospects of that field are somewhat limited given, it's using a primary food source. There is another category that uses, that's more on the line of renewable biodiesel. And you will see companies are primarily using animal fats and waste cooking oils and things of that nature to make fuels. Now, these two areas that I already mentioned, generally speaking, they are established and you are able to produce biofuels successfully. But if you look at the amount of feedstock that is available, you are very much limited on how much feedstock you can use. The category of feedstock that is really widely available is the third category, which is agricultural waste and forest residues. And that's where, the cellulosic biofuels come into picture. In fact, recently, some of the analysts from United Airlines did the analysis because they are big into using SAF, the sustainable aviation fuels. And they were looking at this and they were saying there is less than 1%, much less than 1% of supply of feedstock or fuel is going to be available compared to what they are planning to use for SAF. So long story short, if you look at these sources, cooking oils and animal fat or the traditional corn to ethanol, there is limited scope there. So your avenue to get to the projected consumption or the interest in SAF is looking at agricultural waste and forest residue. But the challenge, if you look at the materials that come under that category, so those are wood waste, think of yard waste, material that comes with twigs and dirt and bark and all of that. It's not clean wood chips. There is corn stover, there is bagasse, even municipal solid waste, So all the materials in this category, if you look at them, they are really difficult to handle. And what I have been seeing, I've been working with many demonstration scale and commercial scale facilities for biofuels production, helping them to improve the flow. But because systematic approach was not used early on when the plants were being built, there are limitations to what you can do later on. But what we see oftentimes is to handle these difficult feedstocks, you really need a well-designed system. And if they're not in place, a lot of flow issues occur. So routinely you hear about plugging and arching and rat holing in bins and transfer chutes. So oftentimes what we see is, people always look at chemistry. They are always developing new processes to make biofuels. And the focus is heavy on chemistry. And unfortunately, they take material handling. They just assume that it is going to be the easiest part. And the reality is actually exactly opposite. So long story short, in my opinion, what we have seen is many times companies underestimate the importance of bulk material flow. And as a result, the systems may not work well. Of course, Dr. Jenike developed methodologies many years ago on how to design a solids handling system scientifically to achieve reliable flow based on testing of the bulk materials and looking at its flow characteristics. And there are companies that have used this approach and have seen successful operations. But yeah, overall, to summarize in one sentence, I think the industry, especially the industry handling municipal solid waste and agricultural residue, forest residue, they can benefit by paying more attention to bulk material handling and doing it more systematically.
Really great answer. So Jenike and Johanson has launched a new technology, Gen Zero, to deliver feedstock into high pressure reactors. So can you tell us how it fits into this current biofuels industry picture?
Sure. So, like I already mentioned, many times when you're handling feedstocks, you are likely to experience flow problems if the systems are not designed robustly. But the problems increase multiple fold when you consider delivering that type of feedstock into a high pressure reactor. Because if you look at some of these processes that are used to make biofuels, I'm talking about gasification or pyrolysis, they will use high pressure. And when you are delivering these kind of difficult or tricky feedstocks into that high pressure, not only you are dealing with the regular material flow aspect, but you are also dealing with the resistance or opposition from the high pressure gas that's there in the reactor. So you are feeding this feedstock, which is at ambient pressure, and you are trying to go to the high pressure. So there is a strong opposition that you have to overcome. Typically, what industry does is, they pressurize the feedstock using gas and then send it to the reactor. So one of the most common ways is people will use conventional lock hoppers, which pressurize the feedstock to a pressure a little bit above the high pressure reactor and then discharge into the reactor. But one of the issues when you are doing a conventional lock hopper for these type of materials is these materials have very low bulk density. They don't weigh much. So two things, there is a limited downward force that these materials exert. And secondly, because of their low bulk densities, you need tremendous volumes for the same throughput rate. If you compare the volume that you will need of corn stover compared to, if I were to think coal or pet coke or even wood chips, the volume of corn stover that you would need will be much larger. So you have to feed really large volumes, get them to that high pressure, and then deliver it to the reactor. That really makes the system really complex from a reliability standpoint. So it is critical that the system be designed properly. Otherwise, pluggages and flow problems can occur. So this is where Gen Zero comes into picture, the system that Jenike and Johanson has recently developed. It's a novel technology specifically designed to feed these difficult to handle materials into high pressure reactors. It is novel, patent pending technology. It has several different aspects associated with it that keep the feedstock consolidation to a minimal level, that distribute the feedstock into an array of specifically designed systems that then pressurize the feedstock and deliver to a high pressure reactor. Given the proprietary nature and given the podcast side of things, I cannot show or I cannot describe all the details to a great extent, but the system really focuses on ensuring that difficult to handle feedstock can be delivered to a high pressure environment reliably without any kind of flow issues. And this is particularly suitable, for processes like gasification or high pressure pyrolysis. And the business model that we have is to license this technology where we will design and supply the system based on the specific plant requirements.
So tell us more about the advantages of Gen Zero over currently used technologies.
Sure. So first and foremost, the big thing about Gen Zero is reliable delivery of difficult to handle feedstocks into high pressure environments, whether it's biofuel reactors or whatever other process you may be going into. And again, that's where there are systems out there that can handle easy feedstocks. So for example, if you have wood chips that are nicely cut and that are clean, that don't have any kind of residue and dirt and bark and twigs coming with it, you may be able to handle them with the existing technologies. But when you're talking about feedstocks like corn stover, municipal solid waste, bagasse, or yard waste, because there is a significant supply of forest residue that's also available to make biofuels. But these things, they are not your nice square wood chip. They are twigs, there are splinters. So our technology, the first and foremost advantage is our technology is capable of handling such difficult feedstocks. Secondly, I will say the advantage is that it can handle a wide range of feedstocks without requiring much pre-treatment at all. And I will contrast that by saying, there are companies who are taking the approach of taking such feedstock, for example, forest residue, and they would mill it down really fine, like something to a sawdust type consistency, and then handle it. But you are spending a fortune when you're doing that. So we don't really need that kind of pretreatment. On the other side, there are also companies who would pelletize the feedstock. So they are spending this extra money, and these are OPEX costs. So, they are continuously occurring every single hour as you are delivering the feedstock. So we don't have to pelletize, we don't have to mill it down. We can even handle -2-inch feedstock. So that is really a significant advantage with Gen Zero. And another big thing is Gen Zero is based on positive sealing. So when you are using some of these technologies for feeding into high pressure reactors such as plug screw feeders, there may be concerns about pressure blowback, where depending on the nature of the feedstock, what may happen is the gases from the reactor, they may travel upstream into the feeding bin or other ambient pressure equipment. And that's a major concern. So Gen Zero doesn't have that concern based on the positive sealing that it provides. Also, some of the other features are it continuously delivers the feedstock to the reactor. So it's not a batch process. It's very easy to scale up. We are really excited about this technology.
Really interesting. So, Jayant, you'll be speaking at the upcoming International Biomass Conference, and I have moderated your panels quite a few times in the past. And so I really look forward to your presentation this year. Tell us a little bit about what people can expect to hear in your talk this year.
Sure. All these years I've been at International Biomass Conference. These are great venues to hear about all kinds of technologies associated with biomass. And I've been associated with these events for more than 10 years now. So really wonderful. I want to compliment you guys for putting together such great event year after year. Regarding my upcoming talk, I will be talking and discussing specifics of Gen Zero. So the great thing is we'll be able to show you what the technology looks like, the basic configuration, how it works. And we'll also compare and contrast it against the conventional lock hoppers and plug screw feeders. Really looking forward to it.
No doubt. Well, I just want to thank you so much for coming on the podcast today, and we'll see you soon.
Thank you.
And to our listeners, learn more about the International Biomass Conference and Expo being held March 4th through 6th in Richmond, Virginia at biomassconference.com. Producers get in free, and I hope to see you there. Thanks for tuning in to this podcast. Until next time.